group 2, 9 and 1 and 6, 4. Okay. Okay. So let's move on. So if you have any question, just directly ask me. Okay. Okay. So when you're talking about structures, discontinuity. So what does it mean by structure? So structure means something like building. Okay. We do have structure. Yeah, let me show you something. Okay, like for example, like for building, right? You do have structure, you do have piling, you do have beams, you do have what else? Piles, you do have whatever, like all those structures, right? Piles, beams, whatever, foundations, that are the structures of a building. For example, this one is the building, and those related to what we have, that what I've mentioned earlier. So um, same goes to rock as well. Okay, it's just that rock is happen to have those structures naturally. It's not man-made. So, for example, I give you an example. So, how many floors of KLCC now? How many floors of KLCC now? We have twin tower of KLCC. So, how many floors altogether? Can someone tell how many floors? Or maybe write it in the chat room. 88, yeah. So Hari Haikal is true. It's 88 plus 5. Okay. But knowing Tun Hadi, he wanted it to be 88. So okay, 88. Okay. For example, another new PM is coming. Not Datuk Sri my dear, since someone else said, okay, sorry, it seems like 93 is not a good number, so I want it to be 99. So I want it to be like 6 more levels. So can we do that? Can, because it is man-made. Okay, man-made. It is man-made. So you do it by yourself. We do it. We engineer it. That's why they call it engineer, because it is engineered. It is built by human. It is designed by a human. But it doesn't happen in geology or in any rock types, any rock bodies, any natural structures, because it is not man-made. It is made by external and internal forces. Okay, so Earth's structure, Earth's surface, and its constituents are still undergoing physical changes at continental and regional scale. Okay, why it says it's still undergoing here? Why it still says it's still undergoing? Because it's still undergoing. The earthquake is happening like last 2 days or yesterday. There's a massive earthquake in South Sumatra. There is dynamic changing down there. They are combination of physical and chemical changing in the earth. Okay, that's why people say like, okay, how can the shoreline change? You know, sometimes when you go to this one specific beach area, you said, hey, for the past 10 years I've been here, the shoreline was here, but now it's getting further, it's getting far away from us. For example, this is your car park, something like that. Why is it getting like further? You know, those are evidences saying that the earth is rotating. Okay, fine, earth is rotating, yes, because it's dynamic. And then some more, the physical chemical weathering, whatever, now is still continuing. Okay, that's the reason why we call it geological processes, mechanisms. And then there's also continental drift and collision, erosion and deposition. Okay, continental drift and collision is no longer happen right now recently. Okay, because Yeah, because it's recently, so there's nothing yet happened because there's no continental drift anymore. Continental drift means continents. So you guys, do you guys realize that there's 5 circle for Olympic Games? Do you guys realize that? 5 circles of Olympic Games. Okay, so it's various in colors, right? Because it's represent the continent of the Mother Earth, okay, of the Earth. So these 5 continents were together last time, okay, in the first few million years back, million hundred years back. They were actually together. There was actually you and your friend, you and those friend in Korea were actually together. You and your friend from California, US, UK, all that can be travel, can be crossed, can be travel in the same land, in the same mainland. But due to all these effects of the geological processes, and I call it plate tectonic, I call it as tectonic settings. So all these settings like continental drift, blah 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 blah, and changes of rock made 5 of these continents or 5 of these areas are separated. Okay, and then produce various deformations and changes to the earth crust, continuous reshaping of the earth's surface. For example, collision of continents produce massive mountain range. Same goes to like Semenanjung. I've explained to you so many times. Okay, my map is getting worse and worse from weeks to weeks. So this is the marriage granite, okay, like how you seen it in your Google map last week, your individual task. There's a main range granite over here in the middle of in the middle of the peninsula, Malaysia. For those who have seen it, as well as this is also for Sabah and Sarawakian students. If you see the Sabah Peninsula Malaysia, there's one line we call it main range granite. So that is our backbone. Okay, why is it so massive? And also we call it as mountain range as well. Why? Why is it so massive compared to other mountains? Like for example, who for those who loves hiking, why is that your whatever mountain that you have been to in Malaysia? Why is it reachable? Why is it as not as challenging as Gunung Korbu, the one of the highest mountain in peninsula? Why is not as challenges as Gunung Kinabalu? Why it's not? Why other mountains is not as massive as that? Because it didn't undergo those very challenging or very massive geodynamic over there. So the mountains are only like 500 in depth. For those who have been to Cameron Highlands, both right, both plant, sorry, both tea plant, both tea farm, sorry, both tea farm in Cameron Highlands. It's like just how many feet from your how many feet from the ground, even though you can see like very far from the ground, but yet it's still reachable. As long as it's still reachable, meaning there's a very less geological processes happen at that area. Okay, so that is the very surface of why structures, why the discontinuities is happening, and why is it important? Why is it important? Later on, I will show you guys. Okay. Other changes include expansion of rock body if confining reduces, deforms plastically, ruptures. If acting stress is larger than its strength, fracture like joints, faults, and deform elastically reshapes if the acting stress is smaller than its strength. So there's a stress and strength. Okay. This is stress. Sorry, this is strength. This is stress. This is the E. This is the sigma. Okay. So there is a calculation for this, and for those who will have you guys studied? I don't think so. For those who join the lab 2012, you will have to calculate this one later in your lab work, and that's how to calculate the compressive stress. So whatever, for example, this is the rock samples, this is the raw samples. So whatever stress that you put in, later on it will give some value. And this is the value that we want. Okay. And then it will show, okay, whatever direction is less in this direction. So you can predict like, okay, for example, that wall, for example, just a specific wall of rock. Okay, this one, for example, I give you an example. This one, from the calculation, we can see that the stress is coming from here and here. Okay, the stress is not coming from here. You get what I mean? So from that calculation, okay, from those who study really deep into those stresses, okay, remember, stresses in geology is not like stresses, human stress, okay, but it's the same thing. It's about pressure, okay. It's about pressure and it's about internal and external pressure. So it's called as stress. Okay, there's a three type of stress in geology, but you guys are not be you guys will not be doing a very detail about the stresses, but stresses usually, and of course it's related to the strength. So the more stress it has, the lower strength it will be. Okay, that is the simple calculation for that. So as a result, rock mass displays certain characteristic in is indicating changes in the surrounding. So as I've mentioned, different stress will produce different kind of strength. So if you have, let's say, rock B and rock A, okay, you do same test, and you obtain the samples at the same site, same location, same geology, same block. For example, like for mining area, you got that samples at the same place, same GPS, okay, same longitudinal, latitudinal, same location. But why is this cause you 7? Why is this rock, for example, obtain 7, and why is this got 8 MPa, for example? So what's the difference? So that is the difference. So the difference is between the strength and the stress of the rock. Okay, so don't ask me like is the same material. For example, if you compare slate material and slate material, slate A and slate B will produce the same number of value of compressive stress or compressive strength. The answer is will be no. Okay, but it does have the range. For example, 1 to 20, say it's for gypsum, for example. Okay, so that's it, 1 to 20. If you go beyond, maybe we can tolerate 5. Okay, 5 MPa. If you go beyond, meaning that is not a pure gypsum, for example, like that. Okay, so later on, once you work in industry, you'll be asked to do analysis. Okay, you'll be asked to do some kind of analysis, like slope analysis, for example. Okay, for example, this slope analysis has lots of layers down here. So how to make sure this one and this one is different? Okay, it's based on the strength of the rock. Okay, if it's soil, it's based on the cohesion of the rock. Also, cohesion is about the same as strength for soil as well. Okay, so those parameters are important for you to employ those parameters and then to do analysis. Okay, this one will be collapsed if we don't put blah 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 blah. If we want to do piling over here, we need to do how many meters, because this one is in different rock already, okay, compared to this one and this one, because this one is soft rock, this one is not soft rock, say something like that. Okay, and then depending on the effect of geological processes, rock mass may display structural discontinuities, and most important, these three. Okay, the most important or most talk structures of discontinuities are these three, which is bedded strata, folded, and fault and joints. Okay, we move on to this one. When sediments are deposited in environment of deposition, like seas in ocean, they are generally laid in horizontal position. So horizontal, which one? A or B? A or B? Which one is horizontal? Okay, A, correct. So horizontal, right? So whenever it is deposited, okay. For example, it's like okay, let me show you. Can you guys see me now? Okay. Can you guys see this book? Okay. Can't see it now. Wait. Okay, this book, right? This book. Okay. For example, this is like the first bedding. Okay. This is like the very first bedding. Okay, soon after 3 years, after the deposition, after the running of water, whatever not, then one thing start on top. Okay. And then after years, there's a small thin layer of water being deposited, and then like that. So this one is called as bedded strata. They are in one strata, or in one rock of body of rock, body of material, but it's actually somehow might be in different material. Okay, but they are bedded together, bedded and embedded. So this one, okay. So bed means what? Just like a horizontal plane of 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 one material, right? So it's something like that. Okay. So it's formed by gradual and continuous. So it's continuous, like continue like that. Okay, process of deposition may continue again, forming another sequence of beddings above the earlier bed. So of course, this one is the earlier one. This one is the earlier one. Then this one is the new one. Then it's been deposited, something like that. Okay. So process of deposition might be continue again, forming another sequence of very early one. The process continues to form series of bedding. So this one is called a series of bedding, okay, because it's continually deposited. Something like cake, layer of cake. Just now that I've given you questions, it's like you put one to another, one to another, one to another. Okay, it might sometimes taste the same if you put the same material. Okay, let's say just now I was like matcha layer cake. So if you put matcha to the layer, let's say this one, if you put matcha, if you put chocolate, so it will be chocolate, right? Then you put some cream or whipped cream here in a white color. Okay, fine, whipped cream. What if you change from the chocolate, you put it like strawberry layer sponge cake over here? So it will be different. You know, it depends on what is being deposited. So whatever it takes, the most um the oldest rock will be at the very bottom of the cake. Okay, it's like a layer of cake. Okay, this one will be the most bottom of the layer of the cake. And then what happen if you cross section this material? What will be happen? So this side, of course, this side and this side will be different. Later on, I will show you. Okay. So that is the example. Okay. So bedded strata are separated by bedding planes. So these are discontinuous. These are discontinuities, weakness planes. So sedimentary rocks are not continuous body but separated by bedding planes and therefore weaker. Okay. I open the video again to show you guys how things get weaker. Okay, you have this, right? You have this. Okay, and then you have this one and this one. Okay, this is like your layer of cake, right? So this one, once if I put something in between, I put something in between here. This one. So this one is is easy to separate, isn't it? Because this is the weak plane. You get me? It's not attached. It's not attached. So if it's not attached, it is easier to get detached. You know, it doesn't have anything that connects, that bond, that binds these two layers. So by any time or anything with any chance, if there's anything happen in between, not within this material, but in between this time. So these two parts can be separated. This called as a weakest plane of these two. Okay, you got me? Okay, that is the analogy. Then movement of the earth, there's a three types: compression, tension, and shear. Okay, compression is pulling apart. No, not pulling apart. Pulling two forces into one direction. Shear. This one is pulling apart. Like, no way, I don't want. We go in separate ways. So that is tension. We call it tensile. Okay. And this one is shear. Shear in bahasa Melayu is geser. In between the rock. Okay. So for example, like this one. So this is the best example that I can give you guys to show how the mechanism works. For compression, of course, yeah, it's like this. Compression and tensile is very straightforward. For shear stress, you will be doing this test in your lab later. It's within the material. So this one go this way, this one go this way, something like this. Like there's an internal force, something like this. You get me? They're still in one body. They're still in one rock body mass, but this one goes this way. This one say, okay, I want to go this way, and this one go this way. So it's like they're still in one rock body. They're still in one body, but both wanted to be in different ways. Okay, so there's like internal stresses. We call it as band shear stress or shear stress. Okay. Next, we move on to the fold. Okay, so when horizontal or bedding strata, sedimentary especially rock at depth, are subjected to compressive tectonic stress, they are deformed into waveform. We call it as folded strata or fold. Okay, you can see it from here. This one. Okay, I think I've explained to you in the very first lecture, something like this. Okay. Okay. So the analogy for this is that okay, there used to be a very straight plain land like this. Okay, very basic plain like this. Okay, and then with the external forces from this direction, this one, and also from this direction. So both direction. Okay, this one and this one. So it makes it like this, right? So this one is the forces from this left and right, for example. Okay, same goes to tensile as well. Okay, tensile won't produce fold, but compressive usually will form fold. Okay, so fold, just like you fold your paper, something like this. Okay, it's because of the external forces coming from left and right, so it becoming like this. Okay, and then there's somewhat more forces coming in. So it's already folded like this. For example, it's already uniformly folded like this. Okay, say this one is already uniformly folded hill or mountain range or whatever, and then somehow there's more coming in. So what will happen? So your fold is no longer uniform. It will tilt to this way, or maybe overturn to this way. Okay? Or maybe this way. Like this one, like this picture. In the first one. This one. So it will turn over to something else. It won't be nicely formed like what we have predicted in the schematic diagram usually. So, and what happened to this one? What happened to the surface? It's being eroded, like what we have learned last week. Because of the erosion, because of the degradation, because of the weathering of air, water, CO2, oxygen, and all that. So it will cut off, it will chop off the top of the hill. So that's the reason why sometimes you just can see like a very half or three-quarter or maybe quarter of the fold. Okay, you just can see like, okay, for example, this line, this black line, you cannot like you can no longer see the another black line over here. See? Can you see it? Can you see this one? Like you can't see the another black line over here. It's already here. Here and this one. So it's been gone because it's exposed and it's being weathered and it's being scraped off from this area because of due to the weathering, erosion, deposition and whatnot. Okay, same goes to this one. Depending on stresses, orientation with respect to bedded strata, complex folds are common. And sometimes also depends on the volume of the area. Okay, if the area is too small, you can't really see the good geology occurrences like this. Okay, and then just to let you guys know, there's a name of it like anticline for A. This is how I remember. For A, we call it anticline because it's like A. So syncline is like this. Okay, syncline is the valley. Anticline is the crest. Okay. Next, this is how similar and not similar it is. Okay, have you guys seen layer of cake or maybe cake lapis Sarawak? Cake lapis Sarawak. Okay. Imagine that if you press that cake lapis Sarawak or cake lapis or layered cake, if you press it in different direction, more towards this way, for example, of course you will get this kind of material. Okay, of course you will get this kind, not symmetrical at all. This is how to explain how this left and right flanks or left and right limbs cannot be uniform because it is a natural cause. Okay, it's a naturally made by the universe. Okay, and then for a formal fold, the upper beds extend more, leading to residual tensile stress stored in this layer, in this rock layer. The bottom layer shorten more, residual compressive stress is stored in this layer. So usually they said that this one stored more compressive, this one stored more tensile. Why? Because tensile is something like you pulling it off, like you pulling it apart. This one is pulling apart, while this one is actually looks like it's gathered. It's like gathering closer to each other. So this one, the surface area looks like more to tensile, and this one look like compressive stress accumulated down here. Okay. So relative displacement between beddings leading to formation of residual shear stress at the bedding interface. So residual or remnant stress affects structures like tunnel due to uneven stress distribution in the folded rock body. In the folded rock body. Okay. For example, if you want to build a tunnel down here, okay, you need to cross this building, this whole rock mass, right? So you are actually have to figure out, for example, this one, you have to like actually figure out like, okay, which is where is the stress direction and how are we going to dig in? How are we going to dig in into the tunnel? We want to make like 10 to 50 kilometers tunnel, for example. So how are we going to drive that? So we need to know the direction of stress as well to make sure to avoid any collapse. Okay. Next is that one was fold, remember fold. And then this one also the explanation for fold area with complex folded rock strata is often termed as geological disturbed area. Problem area for construction. Yes, I do agree that because we did experience that during my tunnel time. And then now is the third one. Okay, just now was we're talking about bedding. Okay, bedding strata. Second one is fold, F-O-L-D, fold, lipat. The third one is faults. Okay. Okay, for example, your partner or your mother or your grandmother or your housemate or your roommate said, sorry, Aiman, this is your fault. Okay, what does it mean? If someone say, sorry, this is your fault, Aiman. Okay, sorry, Aiman, I give your name as an example. This is your fault, Afiq, for example. This is your fault, Jia Cheng. This is your fault, Atira. What does it mean if someone say that is your fault? Salah kamu, mistake, okay, true. What else? Bapa yang bersalah dalam hal ni, okay. Okay, how do you feel when you feel like someone put the blame on you? Like, you feel stressed, yes. Yes, you feel very, very stressed, right? Very sad. Okay. When you see someone, when you put something like very big thing to someone's head, for example, like me, they said, Afika, is it your fault? And that's it. So meaning fault is so unforgiven. For example, in a relationship, someone say, we're going to separate, this is your fault, and that's it. Meaning it's a very big sin, it's a very big mistake they've done. So meaning fault is what? It's a big issue. Okay, you cannot fix it anymore. It's something really bad happened. So here fault means fracture between two blocks, okay, two rock blocks, when there has been observable relative displacement. So you can't put them together again. This one, for example. This one you can imagine like a very soft clay or something, but imagine this is like a rock formation. Can you imagine what happened to this? It's like this one goes up, down, this one goes down, this one also goes up, this one doesn't displace, something like that. So this one is strike slip faults. Okay, it's horizontal displacement. This one is normal reverse fault, is vertical displacement. And this one is faults, it's an example of faults. Okay, and of course it's bigger than joints. And this one is the sample of faults as well. Can you see the black colored layer is no longer together? Because it's what? Because it's because there's a fault line over here crossing this line. See this one, right? Can you see this one? Yeah, this one. You can do nothing about it because it's already displaced. It's already like moved, dispersed. For example, if you cut a cake for your birthday, for example, you cut it. Okay, so can you get back this together? Get these two back together in one whole cake, one whole intact cake? No longer. It's no longer there. Okay, because you already cut it and you split it and you displace it. So it's a big thing. Okay, for example, this one. So we call those who's going upwards as hosts and going downwards is graben. Okay, so faults are major discontinuities, can be hundreds to thousands of kilometers in length and can extend throughout the depth of the earth's crust. So its presence can form a boundary limit to transmission of stresses in rock body. So meaning if there's a lot of stress coming out from here, it can be migrated into here and can pull this body down. Okay, can pull this graben down. And this one, if you have more pressure from the downwards direction, so you can push this one up. Okay, it's something like that. So it's a massive thing anyway. So this one is the sample of a lot of faults in this area. We call those area with a lot of fault, we call it as shear zone. Okay, shear zone is where the faults is being accumulated, terkumpul. So everything is here. That's why they call it as. Remember this one? They call it as this one. They call it as this one for fault. That's why this one. They call it as problem area for construction. It's a disturbed area because there's a lot of accumulated this either is fault, it's accumulated in one area. So it's a complex is complex idea of this one. Okay. Why am I jumping this one? Okay. So the large shear displacement in fault may induce dynamic metamorphism. We have discussed earlier when there's volcano, there's a major fault coming here, okay, and then this magma can be transformed the neighborhood rock into metamorphic rock, okay, and then like fault breccia and clay gorge. So gorge means it's look like conglomerates. There's a lot of minerals and rocks all together in one place, okay. Fault traversing a river gives rise to waterfall. So whatever that you've seen in waterfall, I've explained earlier, right? It was actually a contact rock of this one. It's just that there's a fault in between, so it formed to it breaks up the material to be smaller, and then time by time, because of the water of the rain, the water of the waterfall, it changes the shape into round and boulders form, and you look like a very nice color, a very nice shape of pebbles, of boulders at the waterfall. It's due to the weathering and erosion, okay, due to the water, okay. Spring line is a result of groundwater flowing along along this one together, along a fault line, okay. Large faults like 10 to 20 km deep can act as a passage for magma to flow outwards from inside the mantle. Same goes like what we have explained on the metamorphism, okay. So this is the sample. This is the sample of fault breccia gorge. We call it gorge, okay. Broken irregular rock fragments. This one is from another body, like it's from somewhere else, somewhere, different kind of rock. Produce sharing of the interfacing rock blocks on the other sides of the faults is termed as fault breccia, okay, because it's combining, it's bind, it's metamorphose, something like that, okay, and then it's becoming a fault zone. Okay, remember, fault zone, fault is not type of rock, okay, it's not type of rock, it's the mechanism, it's a structure, it's a discontinuities, okay. Okay, this is the sample of San Andreas fault. Two continents plates slide past one to another. Movement of major faults can create mega earthquake. This is due to the earthquake. Okay, so yeah, this area they say they have a small dike over there, over here. So meaning there's a metamorphism can be occurred as well. This area. Okay, this is the sample. And joints. Okay, next is joints. We have talked about bedding strata. We have talked about folds. We have talk about faults. Okay, and then now joints. Okay, joints are fractures which separates rock blocks. So unlike faults, joints do not exhibit anyway very small displacement. They can occur in all rock types. Formation of joints are associated with tensile stress acting within a rock body. So the tensile stress are created by any all of these processes like expansion and shrinking of massive magma body during the cooling process, joint sets that are particular to each other. So joint is formed due to expansion and shrinking, something like this, okay, due to shrinking and expansion and weathering, so there's joint in between, okay. So this is example for granite, the weathered granite, sorry, yeah, this one is weathered granite, this one is weathered shale, okay. So you can see this like small, this is as not as big as faults, this is joints, okay. Joint is like for example, if you do have a piece of cake, you just cut on top of it. So it's like that. It's like joints is like very minimum forces compared to faults, okay? And this we call it as sheet joints because it has a lot of joints altogether accumulated around this area. And then this is like before erosion unloading, this is after unloading. So from the expansion to shrinkage, expansion to shrinkage, it produced a lot of joints in this area. And this is how tension cracks and cracks of fall looks like, and how this one creates joint. And also if there's external extra force, it will create joints over this area. Okay, this is the example for joint system in granite. Okay, there's a three major joints, which is this one. If you see this one, this direction, this one, this direction, and this one. Okay, so it's like this one, and this one. Okay, there's a three directions there. Okay, so important geometrical parameters for joints is deep direction, deep angle, deep direction, and strike. Okay, a group of joint of almost similar geometrical orientation is called joint set. Two or more joint sets that are intersecting each other is termed as joint system. In a joint system, if one joint set is more dominant than other sets, this is called as primary joint sets. Okay. Okay, this is example of primary and secondary joint sets. Okay, this is the example of joints. This is the explanation of the joint. We're not going to do that. This is the sample that I've already explained to you guys. This is the example of waterfall. Okay, and remember that this one that you've seen like very round shape, nice shape, were this kind of rock before. Okay, it's just like a piece of paper, and then it's being joined, it's being forced to be broken up to each other, and then it form like a very fine round rock like this. And then this is the sample, and then this is the RQD being calculated. RQD is the rock quality designation. I will show you guys later. This is the profile of the rock. Okay, igneous rock, when we do profile, is something like this. It's something like this. And for sedimentary rock, it's a bit tricky because it's a soft rock. So the rock orientation might be different. But for jointed igneous rock, for example, like rhyolite, basalt, it will be something like this. Just very straightforward because it's a very strong rock. Okay. Next, okay, what is this? Have you guys experiencing this? What is this? Can anyone answer me? What is this? What do we call this? Can anyone answer me? What is this? And what is this for? Or maybe what is the purpose of doing this on the roadside? Or maybe before check lapisan jalan, okay, might be true. Boleh, valid. Buat jalan, okay. Okay. To break the roads, and not really. Buat jalan, maybe. Okay. The answer is this one is to take the rock samples. Okay. This one we need actually at least 5 people to handle this one. A day before, we need to bring this machine to the site. We need all these 5 people to lift this one up, to bring this one to the particular hole. Let's say in a map, I want 5 holes around this area. For example, I want this one with the coordinate blah 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 blah. Then they will place this one. Okay, and this one is a drilling. This one is actually happen in the petroleum in oil and gas as well. Okay, this is what and how they do. So this one is being drilled down here, to be drilled down here, right? One direction. Sorry, this one is not right. This one is correct. Not right. And it's not right. This one is not right. Okay. This one. Okay, so one direction. So they take about how many meters they want. So they took out the samples. We call it coring of core rock. We call it coring machine. This one. And the sample and the tube is here. So they need to knock. Okay, the value of the knocking, that one, will show the strength of the rock. True, Aina Akila, the kekuatan tanah, the strength of the rock. Okay. So, and they will produce something like this. Okay. From here, there's a magic. Okay, can you see? Okay, for example, this one we start reading from here. Okay, 6.2 until here. Okay, let's say before we drill this one, let's say me Afika says Afika she wanted to build 5 floors of um shop, for example, at this area. So what are we going to do? So I think this one is it has 30 meters at least of rock. Okay, I say 30, 30, 30, 30, and then when they do the samples, oh, it is not 30. So how to read this one? So what happened to this here? There's no rock over here. There's no rock over here. So there's no rock over here as well. So what is actually happened? There also no rock over here. So this area might not be as I predicted. So I predicted to be 30, but it is not 30. They have already drilled, but they can't see 30 figure around here because each one length, this one is 1.5. So altogether should be 29.2. For example, okay, 29.2. So it's not 30. So and then if it's 29.2, so what happened to this one? So this one might be what? Might be mud, might be water, might be air, okay? Might be something else, might be different from what we have predicted before, okay? This actually will help the civil engineer to determine of the depth, determination of um, strength of rock, and also determination of cavity. What if this one we couldn't get granite? For example, this one, let's say, okay, say this one is granite, altogether is granite. What if this one is mud? It's a muddy material. It's not rock. So we can't core. So if you core, it will lose down. It won't be disappeared as rock. It will be something like muddy material. It's like ice cream form. So how can you capture the ice cream form into this RQD? We call it RQD. Okay. So yeah. So that is the issue here. Okay. So these are discontinuities at mineral scale. For mineral scale, for small scale discontinuities, we have two, which is lamination and foliation. Okay, but this topic we almost done, but we are not done yet. I will show you guys the effect or something else. Okay, so this one is the rock samples that to be sent to the lab. Okay, we got this at the lab at the site, and then we will bring this one to the lab. Okay, and later there are another two structures, which is laminations and foliations, like this one. This one is the cleavage, I've explained to you in the first class. And this is the minerals arrangement in the sedimentary that is the results of sedimentation. So they are aligned. Okay, they look like a line like that. And then this is the samples of sandstone and shale. And this one is slaty and schistosity. We have discussed about this in metamorphism, metamorphic rock. And then this is the example of obtained lab test that effected from the lamination and foliation. Okay, can you see the difference between A, B, and C, right? You can see the difference. So here they say that the stress and strain for A is the best. Okay, because of course, because it's opposite to the direction. And then B is the moderate, and C is the worst. Okay, we got a very small strength of rock. Okay, and here is the sample. And here is the example of on how the rock is being broken due to different directions of foliation. See this one. Okay, if it goes in opposite direction, of course you will get better because it's opposite to your force. Okay. Okay, so this one is moderate because the lamination is like this, and this one is a mix of x and y axis. Of course, you will get the smallest strength. Okay. This is also the anisotropy. Anisotropy is something anomaly, something is not right with something, so we call it anisotropy. So high permeability along mineral cleavage, this one is low permeability because it goes in opposite direction, okay? That's why it has low permeability. Permeability is something like passage or laluan for a material to go in, like water or air, okay? And this is type of structural discontinuity we have explained on fault, joint, bedding plane. While for the small scale, we have discussed on the lamination, foliation, and microfractures and voids. Okay, this one and this one not so much, not so much influencing the structures and strength of the rock. And next is the effect of the discontinuities in construction. Large scale, like fall bedding, affect the actual construction such as slopes, tunnel, and foundation. Small scale will actually affect on the lab test or lab scale tests in real life. Okay, this is like not so much like foliation, it's not so much affecting to the slope, for example, but for lab test, yes, because it will produce different number, different value, like I have explained to you here. Okay, this one. Okay, for if you bring these numbers to the side, they'll be like not so much different, about the same. But if you go for the lab test, yes, it's different. Okay. Next, we move on to the rock material and rock mass. Okay, what's the difference between rock material and rock mass? Of course, rock material is the intact one, and rock mass including the discontinuities. Okay, when you're talking about rock mass or rock body, it includes the discontinuities. When we are talking about rock material, we are talking about intact rock, that one rock without any discontinuities. Okay, but this term is we commonly use rock mass or rock body, meaning it's including the small scale and big scale of discontinuous. Okay, so this one is that we have shown earlier in the RQD, and this is the some example of arah kecondongan satah kelemahan, the effect of the weakness plane. Okay, this one. So this one looks very complex, but this is how it influences the deep and deep direction. And the way to take the deep and deep angle direction is like this. I will show you guys later. This one, for example, okay? Okay. Do you know that there's four types of failure for rock slopes in common? So there's plane failure, wedge, toppling like rock fall, and flexural, something like this. Okay. Wedge, it's like if you see rock failures, usually you can classify it to its type of failures, which is plane failure. You can see the slope is like sliding down like this, and this one is like wedge failure. Wedge means like it takes some of the volume of the material like this, and then toppling is like it goes another way. It's like it's overturned and it's fail. And flexural is like one to each in one affecting to each other. Okay, this one is flexural. Okay, so how can you differentiate this? Can anyone tell me how can you differentiate this type of failures? Because if you see it, it's like it's just a normal failure. So if you seen like there's a failure in for example in Bukit Antarabangsa last time, so it's just a failure. So how can you differentiate that? How can you numerical it? How can you differentiate? This one is fractural. No, you can fight with someone. This is not fractural. This is wedge. How can you debate on that? How can you fight that facts? How can you do that? Can anyone suggest? Can anyone suggest? How can you differentiate A, B, C, and D? Can anyone suggest here? Boleh tak differentiate? Boleh tak kita nak banding, kita nak bezakan this one slope yang dah, this one tanah runtuh Yang dah runtuh dah ni. Tapi you can see, okay, this one is A type, this one is B type. Bentuk dia fail. Okay, bentuk dia fail. Boleh, tapi macam mana nak determine by number? After the failure, maybe something like pattern. Yes, it is a pattern. Tapi macam mana nak determine pattern dia dekat saya dah dekat side ni. Saya dah nampak ni, oh this is tanah runtuh. And then macam mana saya nak differentiate? Okay, is this A, B, C, D? Okay, the answer is, saya pergi dekat side, okay, contohnya macam ni lah. Tak tahu ni, yang ni dengan yang ni mungkin sama ke, lain ke, sama ke, tak sama ke. We don't know, right? So, saya pergi dekat side, macam abang ni, saya ambil kompas, saya calculate dia punya dip and dip direction. Macam ni. So, saya dapat. Okay, lepas tu saya group lah. This one is joint set 1, 2, 3, 4. Nak dapat benda ni is by using compass. Okay? Ada skill nak kena belajar. I myself, I just joined UTM for 1 year kan. We actually have planned to do a geological camp. We suggest to do a camping. To practice the students on how to blah 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 blah. Tapi sebab COVID, so we have to call it off lah. So tak jadi. So basically this is how to calculate it. And then after that, kita collect the data, few hundreds of thousands of data yang tadi ni. Yang cakap few hundred or thousand yang ni, okay? Ni bau berapa? Bau 5 kali 4, 5 kali 5. Bau ni dalam 20-30 data. So we need thousands of numbers, kita pergi ambil satu. And then we got the deep direction and strike, minor joint sites. And then we plot it dekat dalam we call equatorial, stereonet. Basically boleh, kalau nak judge dengan mata kasar ni, with your naked eye, boleh macam ni. Kalau dia macam ni, kalau dia nampak sangat-sangat different macam ni, you boleh lah sikit-sikit, you know, you can say boleh lah, this one is bedding plane, yang ni memang flexural. Sebab kan tadi kita belajar flexural ialah dia menyebabkan kawan-kawan lain jatuh juga. This one, yang ni maybe plane failure. Okay, yang ni kalau nampak obvious then it's fine. What if benda tu tak berapa nampak? What if benda tu macam mixture of that? So we got that. Okay, fine. So saya akan plot this one. During my time, we have to plot it manually. Can you imagine? We have to put the needle. Tak ada needle, we have to take like one stick or carilah mana-mana like batang sate macam tu. Plot dekat tengah and then overturn the paper. Pusing paper memang complicated lah last time. Okay. Because we have to do it manually. Sekarang pun you have to do it manually nanti in your fourth year. Tapi to be simplified, then yang tadi, this one will be converted into, akan jadi macam ni. And then akan jadi macam ni. So bila dah dapat macam ni, saya dah lega lah. Macam okay, fine. So what does this mean? It looks like, what is this? Like contour line ke, doktor? Is this contour line? No, it is not. That is this one. That tompok-tompok is, that plotted dots is actually this one to represent the type of failure. This one is a type of failure. Circular type, plane failure, wedge failure, toppling or flexural, this one. Faham tak? So bila kita dah dapat data ni, for example, dah dapat macam ni dah. Dah dapat macam ni. Kan? Dah dapat macam ni. Ni, dah dapat dah. Okay, then kita back to, okay, kita dah dapat macam ni. So you can see, right, this one and this one. You can see this one, right? Yang ni, ada disperse, ada macam ni. Okay, fine. So because of this one has how many joint sets? 1, 2, 3, 4. Okay, kita ada 4 joint sets. So kita refer balik. Okay, what is this anyway? What is this? So we go back here. So, oh, okay. Tadi ada satu yang macam ni. Ada satu lagi yang macam ni. So there you go. You can predict now. Okay. This one is wedge. Kalau dia macam 8, dia adalah wedge. Kalau dia outside, dia adalah toppling. Kalau dia inside, dia adalah plain. Okay, tadi dia macam toppling. So kat sini. So from there kita boleh differentiate from this area. For example, kata kalau dah dapat dari this area, okay, from this area we can see that there are two major slope failures, which is plain and wedge. So dekat situ kita boleh approve, we can approve to that designer that this actually valid because we have done the numerical assumption, numerical analysis. So this one is numerical because it's got to do with numbers, it's got to do with analysis, and it's valid, right? Because we have gone through all these things. So this is the final results of your type of failures, for example. Okay. So whenever you see type of failures, kata kalau nampak macam sama, macam mana nak you differentiate? So that this is how to differentiate. Okay. So I think that's all for today. We can wrap up and see you guys later. So this week has no homework. I will give you correction based on your group work just now that you've given to me. And that's all. Okay. I will give the presentation in the e-learning. Okay. Please check it out later. Okay. Do you guys have any problem or any issues or any questions to ask? Is there any other questions? I think I have answered the questions. Do you have any other questions based on this? No. Okay. So thank you everyone. See you guys later if you have any problem. Okay. But I want to take picture this week. For those who can turn on your camera, please turn on your camera. Who cannot turn on your camera, please do not turn on your camera. Okay, please turn on your camera so that we can take picture this week. How are you guys doing? Okay. Okay. Aiman tak buka kamera, tak nak ke? Then we can take picture and then we can dismiss. Okay. 1, 2, 3. Okay, one more. 1, 2, 3. Okay. Thank you everybody. See you guys later. Take care. Bye. Cabinesh. Happy Deepavali. Cabinesh, happy Deepavali.